Hey space friend, even though we're no longer orbiting the sun, I've still been tracking the night cycle so that I would know when the holidays were coming up. So today, why repair your spaceship when you can do a Halloween project? Today we're going to use a pulsing LED inside a jack-o'-lantern. Why a pulsing LED? Because I need a friend on this spaceship and maybe my pumpkin having a pulse will make me feel like it's alive. There's multiple ways that you can get an LED to pulse, but I want to do it with math using the sine function. Sine is a function that generates sine waves. We can see sine waves in things like ocean waves, audio waves, or radio waves. A sine wave is a geometric waveform that oscillates periodically in a smooth S shape. This smooth wave is perfect for pulsing an LED. This is what the sine function looks like in Arduino. It takes a float as an input and returns a float as an output. This just means it uses decimal numbers instead of integers. We create two float variables for in and out, which we'll use for the sine function below. For the sine function, the input number is an angle. When you vary the angle from 0 to 360 degrees, the wave completes a full circuit. If you go through multiple angles and graph the output of sine, you get a sine wave. The angle is in radians, not degrees. Radians are angles based on pi. When you start at a 0 angle, 180 degrees or halfway around the circle is pi radians, or 3.14. All the way around the circle, or 360 degrees, is 2 times pi radians, or 6.283. Because of this, in order to place angles into the sine function, we use numbers between 0 and 2. That's where the 6.283 in the for statement comes from. We're initializing the n variable as 0 and saying while n is less than 6.283, n equals n plus 0.001. This gives us input values between 0 and 6.283, or 2 times pi. How quickly the LED pulses is based on the amount of time that it takes to go through a whole waveform, which is from 0 to 2 times pi. We're stepping by 0.001. If you add in another 0 to that, then the LED will pulse 10 times slower, and if you take away a 0, then it'll pulse 10 times faster. The sine function always returns a floating point number that ranges from -1 to +1. That by itself kind of messes with the analog right function though, since that takes a range from 0 to 255. No problem though, it just means we need more math. The actual calculation to shift the -1 to +1 to the range that we want is out equals sine n times range plus offset. We want the range of the wave to be between 0 and 255, so we can use half that value for both the range and offset. If we multiply -1 to +1 by 127.5, that gives us a range of -127.5 to +127.5. When we add in the offset of 127.5, that gives us that 0 to 255 range that we want for the analog right function. So now when we get to the analog right function, we're sending the out variable to the pulsing LED. So what I did for my new friend was I used this RGB LED instead of a standalone individual LED. So that way I can switch between red, green, and blue whenever I want to change the colors of the light inside of it. So if you want to do it that way, we've got the LED connected to 5. So just take out the color that's connected to 5, which for me right now is green. Put in a different one into 5. Now it'll pulse blue. Or I can put the red wire into 5 and it will pulse red. If you don't want to use the RGB LED, you can also just use a standalone LED. I also put it inside of a bag so it doesn't touch the pumpkin guts, and then connected it to a battery pack. Now let's turn the lights off so you'll actually believe me that this works. Nice. Now I've got a living, breathing pumpkin with a heartbeat. Now that I've said that out loud, I think I maybe need to go check the ship's oxygen levels again.